So today we'll discuss init containers. So mostly one pod contains one container and encapsulation of container, storage, and network. Sometimes a pod contains multiple containers also. Okay, so that means a single pod, both the containers want to share same network or storage driver. Say we have this kind of requirement, then we are going for both the pods are using the same, like same network and same container. Then the pod contains multiple containers also. The pod can contains multiple containers also, but we have a special requirement. Okay, in the two containers in the pod, first container is the init container. What is that responsibility is, say, assume I have an application server pod. Before that, like it need to confirm whether the database has been working fine or not. That means what init container will confirm is, yes, database is connecting. Then only I will initialize my second pod. Okay, so what is the purpose of init container? Among the two containers, first init container will execute and it confirms some conditions. If that is successful, then only I want to run the main container. If you have that kind of requirements, then we need to go for the init containers. What is the purpose of the init container?
When they are sharing same storage or network.
No. That is two containers, but init container is a special purpose. First, this init container will execute. Okay, that will confirm everything is fine. Then only the main container is getting executed. So can you tell what is the purpose of init container? Among the two containers, init container need to perform some validations or database connections or something is that server is pinging or not. So based on these validations, if it is successful, then only I'm going to run the
init container.
The second one. Then only I'm going to run the second one. Okay, so what is the advantage with that is, okay, say we'll see when, say I have one database pod is there. Say among the two containers, which container will run? Normally, if it is two containers will start. But if it is init container, first init container will start. Okay, so now here one is normal container, second one is init container. So among these two containers, my app container and init my service, which one will run?
It will first run init container.
First init container. In this, it is checking something, NS lookup something. Okay, so the service account, namespace, all these are like working fine or not. If that service is available with the NS lookup, this is starts. Then only this is going to start the my container. Okay, that means first it is validating something is running or not, and if that is successful, then only we are going to run the
Second container.
Yeah, main containers we are going to run. If I have these kind of requirements, normally if I keep both the containers, both will start. But here if I use the init container,
Init container will
container
first
will
initialize.
start, and that will validate. And if it is successful, then only
Another containers will run.
yeah, the main container will run. Okay, so that is the purpose we will go for
Init container.
init containers. So that is the purpose we are going to use the init.
So, sir, it will work while bootstrapping the containers.
Come again?
Will it work while the bootstrapping process of containers?
No. First, it will validate if the init container is successful, then only the main container will start.
Yeah, for the first time, right? Like if you are starting the
Yeah, for the first time.
Yeah.
Okay. So at the time of initialization, only this one, not each and every time. Later,
Yes.
we're going to check the readiness probes. Those we will take care.
Okay.
So one service need to run, then only I want to run it. So till that conditions are met, the main container is not starting. Even if it is started, also there is no use. So I don't have database is there. Even if I start my application, it can't communicate with the database, or secrets are not created yet. So then I can't connect to the passwords. Those things kind of validations we are confirming. Okay, if all those conditions are met, then only the pod is going to communicate. In this is checking that database service is up and running. Then only it starts the main pod. So here each init container must exit successfully. Then only the container starts. Okay, and the pod is the main pod cannot be ready until all init containers have been successful.
Succeeded.
And if the init container fails, again it restarts, and again it need to check that. So by default, that is going to happen. I hope you understand, right? Okay, so then we have one more is there, similar kind of thing. Static pod. Say normally, who is going to manage the parts is like a manager will manage all those, and the scheduler will inform to an agent side to which service it will update. On the agent side to which service it will update. To the kubelet it will apply. It will tell to the kubelet to run the okay, but kubelet directly won't manage. It starts reporting to the like API server, the health of the pod, all those it would be reporting. And if that is not getting the update, then again scheduler will schedule a new pod also. Okay, but here we have a special use case called as static pods. So those are not managed by the manager. Those are managed by the agent itself. Okay, if you have any specific works need to be run on the agent, then you don't take the help of manager. Who is going to manage the static parts?
Kubelets.
Kubelet itself. That means manager or manager components doesn't know this related to this, because that's not deployed from
The manager.
manager. Okay, but not recommended. If you have any special requirements, we will create these kind of static parts. This kubelet itself will create them. Normally in the deployment template, otherwise we have the daemon set or stateful set or pod replica sets. These all can create the pods. The template will have the specifications, which image it need to use, how many replicas use. Based on the template, we need to specify. But now these all the details not coming from the manager. Now agent itself need to manage those, or kubelet service itself need to manage. Okay, and without knowing to the manager. Okay, so if you have these kind of requirements, okay, so then we are going to use
Static pods.
static parts. Okay, so then it tries to like, so what we need to do is, so we need to create a static pod. In any of the path we can keep, but by default we are going to keep in etc Kubernetes manifest. So on which mission we need to do this? On the agent mission, we need to perform this. On the agent mission, we need to go to, what is the name, file name? So what is the folder name? etc Kubernetes manifest. You create a directory. Then we are creating one YAML file, static web.yaml file. This having the pod specification. That is having the pod specification. We are creating one file. Okay, so that is creating one pod. Okay, once you specify that path and restart your kubelet, okay, then that pod would be automatically created. Okay, so in the etc Kubernetes kubelet or manifest, you need to create one YAML file of the which of the pod specification you want, and once you restart your kubelet service from that URL, okay, so then automatically your pod is getting created. Okay, here you need to give the path of it. And once you start the Kubernetes, okay, so this doesn't start reporting to
Manager.
Only on the agent side itself, this pod is running. Okay, say you want to run any specific kind of task on a specific node, then we may use this one. Otherwise, on that specific node itself, if the task need to run, instead of static pod, we can use node selector or node name or node affinity rules also we can use. Okay, if any parts need to be changes in this file itself, we are going to perform. Okay, so what is the purpose of static pods? So who is going to manage the static pods?
Agents.
Kubelet service itself is going to manage. Kubelet service itself is going to manage. Okay, so then so we can create the jobs or cron jobs also. So a job again, a job may create again, a job resource can create one or more pods. Otherwise, we can schedule the pods. Okay, from the job resources. The only one time we want to execute a job creates one or more parts and will continue to reiterate the execution of the parts until the specified number of success. Okay, so when you just want to execute a Python script or maybe backup script, one time it want to run. Okay, but part would be continuously running. Part would be continuously. I want to execute this Perl script. Okay, otherwise I want to use like maybe one Python script. Okay, so that's if we want to run. Only for one time you want to execute, then go for jobs. Okay, so then that when we create this, that job is going to run. When we execute as a pod, it will be continuously running. Okay, it will be continuously running. Okay, so then we want to schedule the pod or multiple pods also we can create using the jobs. So what is the difference between job and the cron job is uh, so when we run this pod, when we run this job, now itself it will execute. But I want to perform that activity at night 11 o'clock. Otherwise, on a scheduled date and time we want to perform. Then in the Kubernetes we can go for cron jobs. So if you have that kind of requirements, then we need to go for the cron jobs we can go. Okay, so we'll revise what are the concepts here we have discussed. So Kubernetes components, everyone practice again the Kubernetes components like the Kubernetes architecture components, everyone just go through. Then some what are the components of master, otherwise the other name for master is control plane. Then we have node, very old word is minion.
Minions.
We can call the minion. Okay, so otherwise worker also we may call. Then we have CNI. One CNI is mandatory in the previous when we install the Kubernetes. What is the CNI we use? What is the CNI we use in the when we install? Calico is the CNI we have used. Calico is the
CNI.
CNI. Okay, so what is that CNI? Okay, then node components. What are the node components we have? So what are the node components? In the node we have kubelet, kubeproxy, kubeproxy, container runtime. On top of that we have the pods. On top of that we have the pods. Okay, so then we have already kube proxy on the agent side, kube proxy and CNI, and how the node to node communication is going to happen. Pod to pod communication. So all pods not mandatory, it would be in the same host. Then how the node to node communication is going to happen and how the pod to pod communication is going to happen. And what is the difference between kubenet is there? One of the internal CNI is there. Even if you have the kubenet, we are not using it. We are using Calico, Flannel, this kind of CNIs. Then kube proxy. And what are the additional? We have dashboard is the GUI kind of thing, and core DNS is one more service is there. So that is the DNS internally pod IPs to host name resolutions. All these are going to happen through core DNS. So then we have the resources we have is the namespace. Okay, what are the default namespaces we'll get? What are the default namespaces we have? The default we have default is there, kube system, kube node list, kube public. So these are all the default namespaces we are going to get it. So these are the default namespaces. And why we are creating the namespace? Our own virtual clusters, and for the multiple teams, if we have, we can allocate the
Resources.
resources. Resource quotas also can be applied based on the namespace. Okay, then the lowest level of objects which we can create is the pods. The lowest level of objects which we can create is the pods. Okay, so here, what are the maximums of Kubernetes? So on each node, how many pods we can run? On each node, how many pods we can
110.
come again?
110, sir.
100 and
10. 10.
yeah, say on each node we can run 110 pods. And how many nodes in cluster? Maximum is 5,000.
5,000.
We don't go for 5,000 and 1,50,000 pods and max of 3 lakhs containers and max of 3 lakhs containers we can use. Okay, so these are all the maximums we are going to use. Okay, but we don't deal with the pods. We'll deal with the pod controllers. So what are the pod controllers we have? Deployment. Say deployment template can contain the specifications of how to create the multiple containers or how to update rollbacks. Okay, all those we are going to manage through deployment itself. And daemon set. On each and every node, if you want to run one pod, then we are going for on each and every node, we need to run one pod. So then we need to go for the daemon set. So then we need to go for stateful sets. So what is the purpose of stateful set is ordered and unique parts need to be created for stateful applications. Even if the part deleted also, we need to get the same pod name, unique ID we need to get. For that purpose, we are going to create the stateful sets. So for stateless applications, we are going to use deployments. For stateful applications, we are going to use the stateful set. For the stateful set, we are going to use it. So then in order to expose these all, so when we create the deployment, we'll get a replica set. Okay, so we'll get a replica set. Very long back, we have a replication controller also. Now we are not using a replication controller, but just go through what is the difference between replica set and replication controller. So we have the slight difference between replica set and replication controller. Okay, so what is the difference between replica set and replication controller? We need to check. We need to check. Replica set can perform the updates, all those. Replication controller doesn't support replication controller we can upgrade also, we can update our rollbacks can be performed, whereas replica set can't perform. So both are for the same purpose. What is the purpose is minimum the number of replicas we have specified in the deployment, those number is running or not, is taken care by minimum that number of replicas are running or not is taken care by replica set. But why we don't create the replica set is, we'll go for deployment itself is, at any point of time, the minimum number of sets should be taken care, but updates or rollbacks are not possible at replica set. Updates or rollbacks are not possible at replica set. So that is the reason we don't create replica set directly. We will create the deployment itself, and deployment itself will create the replica set. Okay, and that many number of parts also is going to be created, and that many number of parts are also getting created with that. Then in order to expose the parts, we have the services. So what are the types of services we have? What are the types of services we have? So we have cluster IP, node port, load balancer, external name. And one more, we have headless service. That's not a type, but we are using for stateful sets. The prerequisite is a headless service. Okay, so what is the purpose of cluster IP? So what is the purpose of service is, to expose the parts. In order to expose the parts are very dynamic kind of thing, and some parts are created, deleted, but the service is used to expose, and it discover the parts, and expose to outside or expose to the users. And what we can do with the cluster IP is, only within the cluster only we can access, not from outside, not from outside. And what is the node port? Using any of the pod, using any of the node IP address from the range of 30,000 to 32,767, we can expose the parts. Okay, so outside also we can expose, but even we'll use the load balancer, any of the cloud-based load balancers like application load balancer or network load balancer, we can expose the parts. And outside we have one name, internally we have one name, then using the external name we can link it. And what is the headless service? What is the headless service? The headless service is prerequisite for stateful set. If you specify cluster IP is none, then instead of the service discovery is going to happen based on the IP address, the discovery is going to happen based on the DNS name. Okay, because in the stateful set, even if a pod deleted, the same DNS name pod may be created, but we are not going to get the same IP address. So that is the reason, for the statefulness, we are going to use the headless service. Then what happens is, even if the pod deleted also, the new pod will have the same DNS name, then the service is going to discover based on the DNS name. Then the user can get the same session or statefulness will get. So that is the purpose. Headless service is the mandatory one for
Stateful set.
the stateful set. Okay, how we can define is it's just like the specification of service itself, but we need to use
Cluster IP as none.
cluster IP as none. Okay, then that's going to be the headless service. Then that would be the headless service. Okay, so then finally we want to use the HTTP and HTTPS traffic, whatever outside is there. We want to redirect instead of using the service, we want to redirect to the services. Then we can use the ingress. So ingress will outside traffic can bring into the cluster and HTTP, HTTPS proxy it can do. Then SSL termination, like TLS termination also is possible. Instead of using the load balancer to expose the traffic, we can use the ingress to expose. And we need to configure the ingress rules also. And one of the prerequisite for ingress is ingress controller we need to deploy. In order to work with the ingress resource, we need to deploy the ingress resource need to be deployed. So that ingress resource, like ingress controller need to be deployed. We have a lot of ingress controllers like Nginx ingress controller, F5 ingress controller, Citrix Netscaler ingress controller. Okay, say Azure having Azure ingress controller with application gateway. So there we are going to use the Nginx ingress controller, we can tell. So we are using Nginx ingress controller to deploy the applications. Okay, so we can do the path-based routing or URL-based routing or host-based routing also we can do through ingress, and we can add the like TLS termination also. The HTTPS topic, what is coming from the outside, can be encrypted into HTTP. So that is also one of the purpose we'll go for ingress. Okay, so once we do this, we want the persistency of this. For that, we need to create a storage class. After you create the storage class, we need to go for PV. Then PVC need to be created. PV and PVC also we need to create. So once we create the storage class PV and PVC, then we need to create for the stateful sets or for parts for the persistency we are going to mount it. Okay, and what is the config map? So why we'll use config map? If you want to pass the multiple environment variables, okay, so for different environments, for dev QA, so those values better to pass as config map. If it is non-sensitive details, we are going to send them as if it is non-sensitive details, we are going to send them as
Config maps.
config maps. Okay. If it is sensitive details, then we are going to send them as
Secrets.
secrets. So we need to create the opaque kind of secrets, encrypted them, then those we need to use it. Okay, so then we need to use those secrets. Okay, so then we can allocate the resource quotas. Okay, so we can assign even at the namespace level, we can assign and at the pod level also we can specify. Okay, so what's going to happen is if I assign the CPU and memory, some parts may require more CPU and more memory. Okay, so now here in this, we're going to allocate the like how much CPU you want, how much memory you want, like this we can assign. Okay. and memory resources also. Sometimes if memory may be getting crashed with like crash out of memory exceptions, OOM, out of memory exceptions. Then assume in the request we have given 100 MI, and maybe then what you need to do is try to increase the resources. So request itself maybe give 200, limits may give 300 kind of thing. Okay. So when we need to increase the resource quota is you are keep on checking some of the parts are getting out of memory exceptions, and those are getting restarted frequently. And when we go and check the logs, we are getting out of memory exceptions. Then for those parts, better to increase the. Okay, how we can increase is in the specification of the pod or deployment. So we need to specify the request and limits. Request is minimum how much it is going to assign. Limit is
The maximum, sir. Yeah.
the limit is the maximum which can be attached. Okay, so limit is the maximum which can be attached. So accordingly, we are going to assign the CPU, memory, all these can be attached. At the namespace level also we can assign the resource quotas, all these also we can assign. Okay, so then what is a HPA? What is the HPA? Horizontal pod, autoscaler. So using the HPA, automatically we can scale up and scale down the parts depends upon the automatically we can assign the parts. Okay. So what is the advantage is if the more load comes unexpectedly, we can increase more number of parts based on the CPU metrics, otherwise disk IO, otherwise custom metrics, we can perform the HPA. Okay. Say HPA resource we need to attach to the part specifications. Okay. Then we have a node affinity. Okay. And pod affinity rules. So node affinity and pod affinity rules will make sure the parts are going to schedule to the specific nodes itself. And if both the parts want to run on the same node, then we need to specify the pod affinity rules. And we have one more is there, taints and tolerations. Say it's exact opposite to the node affinity. I don't want to attach parts which are scheduled for reserved for them. For this itself, I want to use. Then I need to use the taint and tolerations. If I use the taints to the nodes, those doesn't attract other parts. Only with the tolerations which are coming for those parts only it allows. For that purpose, we are going to use the taints and tolerations. We'll make sure only for the reserved nodes can be attached to those specific parts itself. For others, it doesn't allow to run that. Okay, after taint and tolerations, we have the probes. So what are the probes we have? What are the probes? Liveness probe, readiness probe, then startup probe. Okay. So what liveness probe will do? If any of the pod is deadlocked, instead of we go and restart that pod, automatically it can be restarted. Automatically the pod can be restarted if we go for liveness probe. And what readiness probe will do? What readiness probe will do? Readiness probe, say if any of the pod is not reporting to service, then that service is excluding that pod from the load balancer. Okay, then that service not going to assign to the users. At any point of time, users will get the ready pod itself. And the startup probe, if you use the startup probe and your container or your pod is taking more time to start, then like it will suppress liveness probe and start readiness probe at the time of startup. That is the purpose we are going to use the startup probes, these things. Okay, so we have one more resource is there, RBAC. I think I'm forgetting every RBAC. We'll discuss RBAC also in the tomorrow class. And what is a cluster autoscaler? They're using AWS EKS or AKS. Automatically, we can increase or decrease the nodes as per the more parts. Or HBA is keep on increasing the parts. But a cluster autoscaler will do. The cluster autoscaler, what it will do? It will scale up or scale down the clusters. Okay, scale up or scale down of the clusters can be done through cluster autoscaler. Okay, so in EKS we can do, but in the physical infrastructure, it's not possible to go for the cluster autoscaler. In the physical infrastructure, it's not possible to go for cluster autoscaler. Okay, so we'll stop here. So just go through all these and for each and every resource what we have written, prepare all the YAML files, sample YAML files also prepare. Okay, so one YAML file maybe people will ask us in the interview. That's the reason prepare all the YAML specifications. Then these all we can, instead of using the multiple manifest files, we have a package that is there in the Kubernetes. That is the Helm chart. We can use the Helm chart for this purpose. Okay, and try to spin up the different ways. Try to spin up the Kubernetes cluster and all these resources practice in the cut code also. In the cut code also practice all these resources. We have more than 120 tutorials are there. Try to finish all those tutorials. Tomorrow we'll discuss RBAC and how we can provision the cluster through EKS. We'll discuss. Meanwhile, try to create a cluster through EKS also. Through GUI, easily we can create. Just like how we create an EC2 instance, we need to create a EKS cluster. Try to create the EKS cluster. Okay. Come again.
So this notes.
I didn't get you.
Today's notes, sir.
Yeah. I have shared, please check. Please download that. Okay.